Nice of you to join me. Today, we're going to be doing a review for problem set number 5. Let's get started. All right, boys. Let's hope this works. I can go ahead and erase all of this stuff, right? So, we have problem set. Oh, that is not thick enough. You know what is thick enough? No! This is all I care about. My mom's stuff is in shambles, though. God, I'm getting a call. The dealership. Holy freaking smokatelli, bro. Hold up. I gotta pause the recording. Holy smokes. Oh, no. Holy crap, bro. My mom is definitely not gonna let me hear the end of that one later. All right. So we have our solution, right? So what we're going to need to know for this problem is Newton's second law, since we are talking about force and acceleration and mass. Newton's second law. We have the law that states force is equal to mass times acceleration. So the task is asking us to draw an acceleration graph. So we know by doing some algebraic manipulation that acceleration is equal to force divided by mass. So we have our mass here. Our mass is 2 kilos. And our force graph is represented by this. So an easy way to get the acceleration versus time graph is dividing all of these numbers by 2. Divided by 2. And this is now not the force, but the force graph divided by m, which is equal to the acceleration graph, acceleration in x. This is problem set number 5, question number 3. All right, next. All right, so this question is asking us to find the values of acceleration in the x and the y. So first of all, we have our forces, right? This is the forces acting upon a 2 kilogram object right here. There's a triangle here that says 20 degrees. Here, we can extend this triangle. This is a 90 degree. This is by definition, 90 plus 20, 110. This is 70 degrees. And if this is a 90 degree angle, then that means that this one must be 20 degrees. So we know that the angle between those is 20 degrees, so I'll erase that. So we can rewrite here that this is 20 degrees. Okay, so complete this here. So in order to find the acceleration, we have to do a sum of forces. So I'm going to start here by doing the sum of forces in the y direction. So this is equal to mass times acceleration. Force is equal to mass times acceleration. And this is equal to, we have a 2.82 Newton force, right? And we can assume this object might not be moving up and down, but we'll see soon. So we can do the sum of forces, and we can do 2.82 newtons, because that's positive, right? First, 2.82 newtons plus, and in order to find the y component of this vector here, it's this right here. So we have the triangle, if we're going to take it out this way. Oh, that's such a bad triangle. So the triangle, right? Boom. And I'll write SOHCAHTOA so we can know. All right, so in order to find this adjacent side, we have the hypotenuse defined, and we want to find the adjacent. So the one that involves adjacent and hypotenuse is cosine. So we would have cosine is equal to adjacent over hypotenuse. And if we're solving for the adjacent, we would get h cosine of theta is equal to adjacent. So, oh, sorry, not theta. H cosine of the angle. Sorry. Yeah, no. H cosine of the angle, which would be 20 degrees. I screwed that one up. Okay. Wait, why is my pen acting weird now? Okay, so after we solve this, h obviously is the hypotenuse. So we can say plus 3 cosine of 20. Okay, and this should be equal to a number we'll find right now. And the sum of the forces in x, this is equal to mass times acceleration. And we have 5 newtons. This is the positive direction. So we have 5 newtons minus 1 newton. And we have not the cosine, but this right here, which is the opposite side, and the hypotenuse is defined. So the hypotenuse and opposite means sine. See? So if we want to solve for this, we have S is equal to O over H. And this means sine, H sine theta is equal to opposite. And that's the side we want to find. The side opposite, which is here. The side opposite to the angle. So we have minus, because these are both minus. Sorry, this should be a minus as well, because they're both, it's going in the negative x. This is the negative and negative quadrant. This is quadrant 3, or 1, 2, 3. Quadrant 3. Okay, so this is minus. So let me rewrite this. This is minus 3 cosine, and this is minus 3 sine of 20. Okay, so give me 1 second. I'll be really quick to calculate these numbers, and I'll resume the recording. All right, so just continuing on the solution, we have here. No! Let go! Okay, I just yelled in your guys' ear. So I went ahead and solved for acceleration. So this is what we got for the newtons, the force in each direction. My mom's calling me. Hold up. 669,945. Hello? It's 669,945. Thank you, man. All right, bye. Tiny interruption. So here we go. Forget this. Don't sign into my Apple ID, right? No, but so I divided the force in the y divided by the mass, and I got 0 meters per second. This is for the y. And for the acceleration in x, I have here that I divided this, which is the newtons, the force, divided by the mass, which is this should be in kilograms, right? And I got about 1.5. And these check out with the answers that the problem set gave. Thank you for coming to my solution. Or can I stop it? Where's my mouse?